Hello everyone. In this video, we will discuss about wiring module in SPI. So this video will have so many parts, and in all the parts we will see how to do the wiring in SmartPlant Instrumentation. So what we learn here in this module, first of all we will understand the wiring concept, then we will see about basic things in SPI before start working in SPI for wiring, and then creating reference junction box panel, creating reference DCS panel, marshalling panel and cable in SPI. Again we will see how to copy the reference junction box, marshalling panel, DCS panel and cable to domain explorer or the plant for what we are working. Then we will work on the making connections, means how to do the wiring, how to connect the cable from one end to second end. So from the field to the system side, these complete wiring connections we will see in this part. After that, IO assignment and signal flow, and then wiring modifications. Sometimes we need to do some modifications in wiring, we will see in that part, and in last we will make the revision and report generation. So let's start with understanding the wiring concept. Here these are the instruments, and then this is the junction box, this is the marshalling cabinet, this is the system or DCS or PLC system, and this is the workstation, sometimes called EWS, that is engineering workstations. So these are the component of complete wiring from field to the control room. So these are the instruments. Basically this will be on field, and the junction box also it can be on field. So from each field instrument to the junction box there will be wiring. Again from the junction box to the marshalling cabinet there will be multi-pair cables or main cable wiring, and there will be wiring between marshalling cabinet to the system cabinet. So sometimes these marshallings and DCS cabinet will be in the same building, so there will be inter-building wiring. And after this system cabinet, these are the communications wiring, that is not part of this wiring basically, but this also we need to do at side. So this is the communication wiring from system cabinet to the data communications network, or you can say wiring with the workstations. So there will be engineering workstation, operating workstations, there will be printer, there will be other types of panels also. So these are the complete schematic diagram of wiring from field instrument up to the control. So you can see the signal is flowing from field to the junction box, and then junction box to the marshalling and toward the DCS cabinet. You can see by this way the signal will go into. So by this way we need to do the wiring also. So there will be multiple steps, 1, 2, 3, 4, 5. So we have described to the 5 steps of signal transformations from field to the data communications. And whenever you will do the SPI wiring, then you need to understand the same complex with this single line diagram. You can see these are the tag number of the field instruments, and these are the symbols of device units of field instruments. From the device panel we need to connect a cable. So this is the end one of the cable, and the end two cables will be connected to the junction box, and these are the individual pair cables. You can see from each device of cables will be connected from the device panel to the junction box, and this is the junction box number. And this is the, again there will be a cable, this is called multi-pair cable or main cables. So there will be multi number of cables inside this one main cable, and this cable N2 will be connected to the marshalling cabinet, and from the marshalling cabinet and between the system cabinet there will be also wiring. So these complete wiring we need to do in SPI, and we need to take the report. So before the doing the wiring, we need to create the device panel, we need to create the cables, that means individual cable, all components like junction box, main cable, marshalling cabinet, these cables, and the system cabinet, everything first of all we need to create, then we can do the wiring. And these are the some symbols are there, like this is the junction box, and this is the plug and socket junction box, this is the marshalling cabinet, this is the system cabinet, or any other cabinets you want to create, and this is the device panels and the plug and socket device panels, DCS control system cabinet, and this is the PLC control system cabinet. So these are the symbol of different panels and device panels, uh, you can say. So every symbols you can see in SPI also. So by these symbols you can understand what is the meaning of these symbols. Whenever you create any panels like junction box or marshalling rack or any cabinet, then you can create the panels and then its terminal strip, and inside the terminal strip there will be terminal. So this philosophy we need to consider while working in SPI for any kinds of panel. But whenever you will work on the DCS panels, if you want to create a DCS panel, then first of all you need to create a panel, then you need to create a rack, then you need to create a slot. Inside the slot there will be IO card, inside the IO card there will be terminal strip, and terminal strip there will be terminal. So for DCS panel, this philosophy should be followed. Now we can see this is the SPI, there is a domain explorer, and this is the reference explorer. So before we start working in wiring section, first of all we need to see some basic things in SPI. Like if you want to check where are these panels will be there, sometimes you need to see where you can create the reference panels or reference cables. So see, this is the domain explorer, and in this domain explorer this is your project. This is called just a reference is IOCL refinery. So this is your project, suppose. Similarly, if you are working for different project, then that will also be configured here. You can expand that. There will be multiple area, multiple units will be there. So this is the domain explorer where your project is configured. So if you want to work directly in your domain explorer, then you can work from here. But if anything you want to create as a reference, then you need to work in reference explorer. So whatever the panels you want to create, that will require to create in panel. And if you want to create a cable, then you can create here. Any wiring equipment other you want to create, then you can use this folder. So basically these folders are already there in Reference Explorer. You cannot delete it or you cannot modify it. This is the standard folder which is already in Reference Explorer. Similarly, if you want to check whether your panels, suppose you did some wiring in your project. So if you want to check any panels, you want to open report also, then you can find it from the folder that is called panel by category or panel by location also sometimes. So basically you can see if you will expand the panel by category, then there's a folder of junction box, marshalling deck, cabinet, device panel, and DCS panel, PLC panel, telecom panel. These are the folders are already there. So if you want to create any junction box, then you can use this folder, and if you want to create any marshalling, then you can use this folder. So there is a question why we are using this reference explorer. So basically reference explorer is used for creating any reference panels or reference cables or reference device panel that is required in our project. Suppose if you need a junction box, then you can create the junction box here also in the project only. But why we are using the reference explorer? Because we have multiple types of junction boxes with multiple number of junction boxes required in our project. So what we can do, we can create some reference junction boxes, some different types of junction boxes based on the category required in our project. So we can create as a reference, and that reference part we can use in our project. How we can use? First of all, we can create in reference explorer any box, and then we can select and drag and drop it into our domain explorer. So by this way, we can use any panels, any cables as a reference, then we can use in our project also. So during the instrument index model, you have already seen that we were selecting the device panel and the device panel cable to the instrument by selecting it. So it was reflecting from the reference explorer only. Device panel, you were seeing that it was reflecting from the reference explorer only. So if your reference explorer device panel will be empty, then you cannot select a device panel while working in instrument index module. Also, if you are trying to do the wiring, then field instruments have device panel where you can connect your cable. Without device panel, you cannot connect your cable. At least you need device panel for each types of instruments or field instruments. That we did already during the instrument index module. In this part, that means if you have missed to select the device panel to a particular instrument type during the instrument index module, then at this stage you need to do the same things. Means first of all, you need to select the device panel to that particular instrument type, then only you can start working on wiring. Because without device panel, whenever you will go to the connection, it will not show. Any device panel will not show, then you cannot do the wiring. Means where you will connect the cable, so it will not show. So first of all, we need to ensure that each types of instrument have the device panel. And sometimes suppose you have selected the device panel but still it is not showing during the wiring, then what you can do, you can right click on the instrument and there will be option for create device panel and associated cable. So that part you need to do. Once you will do, the pop-up window will appear that will show that your device panel and associated cable has been generated successfully. Let's do this with examples. Suppose we can go with any particular area, and in that area we can go with any types of instruments. So suppose we have selected this instrument. So if during the wiring, suppose you want to connect this instrument to a particular junction box, but you are not able to see the cable and device panel with this transmitter. So what you can do, you can right click on this instrument, go to the action and go to the device panel and cable creation option. So this is the create device panel cable. Once you will do the right click, then a window will pop up like device panel and cable have been propagated successfully. That means you can do the wiring for this transmitter. So what will happen? A device panel will be generated and associated cable also will be generated if you did the things of device panel association during the instrument index module. If still you have not assigned a particular device panel with associated cable to this instrument type, then there will be error in this result. It will show that you cannot do the device panels connections or cable propagation connections. So first of all, we need to go back to the instrument module and we need to connect the device panel and associated cable. Then we can start the. So by this way we can do this part. We can find the multiple number of panels from this panel locations. We can create the reference panel and reference cables here. So this is the basic things we need to do. Sometimes we need to do the preferences settings that we need to do from here, but this is a part of admin. If they can do it, otherwise they can show you or so they can give you some reference that you need to set up here in the wiring or loop drawing. This is the general setting. Sometimes we will ask for IO card, IO assignment, so they can ask you to do this particular settings. That we will see in different lecture if it is required, otherwise it is not required, but because this is the part of admin. So this is all about basic things about SPI. in wiring module. In next video, we will start creating the panels, the cables, and the other accessories which is required for the wiring. Hello everyone, welcome to next video of wiring module. In this module, we will learn about device panel, junction box, marshalling cabinet, and cable creation and reference export. So first of all, you have to create these panels in Reference Explorer. You can open the Reference Explorer from Tools option. Go to the Tools options, and once you will click on this, there will be Reference Explorer. So you can open it by clicking options, or you can directly open it by pressing F8 button in keyboard. I already opened this Reference Explorer. So here you can see in the Reference Explorer, there is a panel options and second one is cable options. So once you will click on panel options plus buttons, then you can see there are so many options like junction box, mastering rack, other cabinets, device panel, DCS panel, PLC panel and telecom panel. Any panels or any cabinet you can create any of these folders. So first of all, let's create a junction box, because junction box is one of the device which is used in instrumentation. So in wiring, you will use junction box. For field instrument, connect to the junction box, and from the junction box, multi-pair cable will go towards the control. So junction box we can create from here in references. So how you will create the junction box? By right clicking on the junction box folder, you can see a window will open showing new. So once you will click on this new options, you will be having two options. One is junction box generic and second one junction box plugin software. So we use generic options because in our industry, generic junction box is preferred. So once you will click on the junction box generic options, a window will open for junction box property, where it is asking for the junction box panel. So we can put it as, it can be anything based on your requirement. For knowing purpose, we can mention it 16 instrument AI JB. So this junction box is dedicated to analog input signals, and there will be 16 number of instrument can be connected within this junction box. So this is the name, and for the type, you can consider it the field instrument. If anything it is not showing here, you can put it here. New options. This junction box you are making for the field instrument. Conventional. Field instrument. So I am clicking OK. So this junction box is for conventional field instrument, and the manufacturer, model number, dimensions, these informations you can put later on once you will receive these informations from vendor. And mounting details, these are the information you can put it later stages. And if any area classification you can put here by drag and drop option. If your area is not showing here, you can go with these options. You can create your area of JARDES. So I'm putting is zone 1 GR 2A and 2B, temperature class T3. There is a character limitation, so we can reduce the spacing between them. T. Then further character limitation. T. 3. And put it like that. So whatever the information you will have, you can put here. There is option of rack also if you want to create rack within this junction box. Otherwise, you can skip it. Normally, we not need a rack within the junction box because we are considering the junction box for only AI instruments. But suppose you are considering AI, AO, DI, DO in the same junction box, then you need to make a different racks within the junction box. So I'm clicking OK. So your junction box is created. Once you will click on the junction box plus button, then you will see there is a junction box created. But still, you did not have created any terminals or terminal strip within this junction box. So go to the junction box options, create new, and create the terminal strips. Because junction box will be having terminal strips so that you can connect the instrument within this. So we are considering the junction box with 16 instruments, then total number of terminal will be increased because we require the more terminals. It is by default is showing 16 instruments with IS, but the total number of terminal is 24 only. So we can create it the number of terminal this, and the total number of terminals we can increase to 48. We can consider it 52. And, suppose we are creating for 48 only. Okay, and the configuration name is 16 instrument AI JB TS. So this will be the flash instrumented. Plus minus, and this will be the shield option. By this way, you can put it some informations like this is your terminal strip configuration name, and this is the configuration descriptions. Total number of terminals will be 48 because each instrument required 3 terminals plus, minus, and shield. And if you can use the 16 number of instruments, then 16 into 3 is equal to 48 terminals at least required. You can use more terminal also, but at least 48 terminal will be required. And the first terminal will be 1, and the number of terminal per channel, it is 0. First channel is 0 because we are not considering channel within the junction box. So you can create it, and again it is asking for the terminal strip name that will show in your wiring once you will create the wiring report. So this is the 16 INSTTS, and you can also put more details like AITS. Details already we can fill it blank and go to the option 16. Once you will expand it, you can see these are the, you can see these are the terminals number are there, 1 plus, 1 minus, and 1. This is the, I think something wrong. with the third terminals because third terminals should be sealed. So basically we are considering for the sealed only, but if you want to make it, then go to its options, go to the property, and you can correct it 1%. Go to its properties. We can create a new terminal script, then we can see what is the problem actually. So new 3 68 68 AI incremented and plus minus C. Total number of terms will be 48. We'll save and create 16 and yes. AI. Yes. So you can see uh, 1 plus 1 minus 1sh, 2 plus 2 minus 2sh. So we have generated these terminals within the terminal strip. So what was happened in above where it is not showing because we have considered the third terminal as incremented only, but it was missed to mention sealed in the third terminal. So that's why it is not showing here. So you can see this terminal strip is for 16 instrument terminal strip for AI. So necessarily this was created, so we can delete it from here. So go to the right click and go to the delete options. So you can delete any unwanted terminals. So this is the junction box you can create it. So once you want to check whether your junction box how it will look like, so you can use it in your domain explorer and you can create it as a connection so you can see how it is look like. So we will see later on how to use this junction box in our domain explorer by copying options. Here only we are seeing that how to create a junction box. So always remember you need to create a panel. In panel you need to create terminal strip. In the terminal strip you need to create the terminals. So there is terminal. So one in first instruments you will connect on these three terminals. So at least suppose you are considering a transmitter, it is going to connect with this junction box. So a transmitter's individual cable will be having one pair with shield. So in one pair there will be two wire plus one shield wire. So one wire will be having plus options, second wire will be a minus options, and third wire will be shield options. So these three wires will be connected to these three terminals. So at least you can use these three terminals for one instrument wiring. Similarly, you can use other terminals also for other instruments wiring. So maximum you can consider the 16 number of instruments connected to this junction box, because we are considering the 16 instrument JB. But yes, there is a philosophy in the project. You cannot fill your junction box 100%. Some spare philosophy you need to consider. So based on the project requirement, you can use the spare philosophy like 30%, 20%, 15% number of spare instruments. So suppose there is 16 number of instruments maximum you can connect, so you can connect only 14, only 13 based on your requirement. So this is the 16 instrument junction box. Similarly, if you want to create a 24 number of instrument connection JB, then you can use this method only. Because based on the number of instrument density at a place where you want to use a junction box, you consider the junction box. So there's a workout in junction box grouping, how we can select the number of instrument to a JP. If there are so many instruments within the certain area, and if you will use the very less number of instrument connected to the JB, then what will happen? Number of JB will increase. By this way, junction box cost will be increased, and also the cable cost will be increased. So ultimately, the purpose of using junction box is to reduce the cable cost as well as considering the JB number of cars. So if the number of instruments in certain locations are more, then you can use the high capacity of junction box. If the number of instrument density is low, so you can use the lower number of instrument connection to the JP. So by this way, 8 instrument, 10 instrument, 12 instrument, 16 instrument, 24 instrument, as per your requirement, you can consider the junction box capacity. But the generation methods will be same for the junction box. Similarly, if you want to create for the digital junction box, then what you can do for the digital junction box, you do not need to consider the shield option. So in that case, you will require only two terminals. So you can provide the numbering either 1 plus 1 minus, or you can provide just 1, 2, 3, 4 numbering, so that you cannot use the shield option. So let us see how you can create the digital junction box. So by this way, you can go with, suppose we are considering 24 DI JB, and we can skip these options. You can fill it with as per your requirement. So again, go to the new options, go to the terminal strips, and you can go with the new options. The number of terminals in patterns will be 2 in this case, and this will be the DI INST TS, and the number of total terminals will be 48 in this case also, and the first terminals will be 1 incremented. So here if you want to common an NO or MC, you can use, otherwise simply you can use the plus or minus, or you can let it blank. So here we are considering the blank because we don't know what will be the suffix philosophy in your project. So considering this, you can create it. Now write the name of terminal strip, so it will be DIINST TS. Hit on OK, so it is created. So by this way you can see 1 1 2 2 3 3 4 4. By this way we have created 48 terminals, and we have considered 1 1 2 times because for the first instrument there will be at least two terminals required. Suppose there is a switch DI, so at least one terminals will be common, second terminal either will be NO or NC. So again I am repeating, you can use this 1 1 2 2 philosophy as per your requirement. You can use 1 plus 1 minus or 1 common, 1 NO or 1 NC as per your requirement. So this is the way of creating junction box. So first of all, what we need to do before creating the junction box, we have to analyze the project requirement. How many types of junction box we required in the project, like how many AI, how many DI, how many DO, and how many AO type junction boxes are required. Normally, we can consider AI and AO instrument in the same junction box, and we can consider the DI and DO for different junction boxes. So first of all, we need to see how many different types of junction box required in our project. That different configurations we can create here in Reference Explorer. Then we can use these types of JB in our projects. Suppose you want to make some changes within the junction box, and you can also use, just like if you want two terminal steps within the same junction box, then just right click this terminal strip and duplicate it. And by renaming its terminal strip name, you can see there will be two number terminal strips created. So duplicate option is very important to reduce your time and effort in wiring options. Everywhere we can use these options. Suppose later on you find that there is one more terminal is required, that is for overall sheet, and you miss to create here, then you can use this duplicate options, and once you will go, then it will show the same options, and you can see the terminal is showing 16sh, but you can uh, provide its name for all field options. And where it will show, it can show in between also if you will not provide sequence number. So there will be the last sequence number for this terminal. So what will be the last sequence number is 49. Once you will click, then you can see in the last there is overall field terminal is also created. So by this way you can add or delete any terminals, but this could increase your working time, because again you have to modify your junction boxes. So before creating any reference junction boxes, you must see your requirement, or you must see your vendor documents. Like for your junction box, vendor will provide the junction box GAT, where all the terminals will show. So by this way we can create the junction boxes.